Now let us see few more examples. Now make a note of this particular design and waveform and try to write the constraints so that it will become practice for you. So let me explain. Initially we need to apply some clock at CLK. So create clock hyphen period 10 nanoseconds hyphen name CLK get ports CLK. So I am applying a clock which is having a time period of 10 nanosecond. Now I want create generated clock, that is at GCLK and GCLK2 I need to write this particular constraint. So create generated clock hyphen name is GCLK hyphen source, it is coming from CLK. So get port CLK and it is nothing but divide by 2. Why? Because you can see this particular waveform. These are the rising edges. So it is being high till here and going low, and again this repeats. So hyphen divide by 2 get pins flip flop 1 Q. So this should be written as flip flop 1 and Q. Here also it will be like flip flop 1 and this is something called as Q bar. But the difference here, bubble is there. So you have to use one extra switch called as invert if you are writing for GCLK2. So see here, create generated clock hyphen name GCLK1 source coming from clock divide by 2. It is at pin flip flop 1 Q. Next for GCLK2 source is same divide by 2 and hyphen invert. This is very important. Why? Because there is a bubble. If you observe here, there is a bubble which is inverting. So hyphen invert get pin flip flop 1 Q bar. So simply this is a nomenclature which I am following. This is D, this is Q, this is Q bar and this is CK clock pin. So this is how we need to write the constraint for this particular design. Now let us see for this particular one. So you can see here this is negative edge. So positive edge is something, it will be like this. So let me draw it clearly. So if you take one flip flop, this is D pin, this is CK, this is Q, this is Q bar. If it is negative edge trigger, then there will be a bubble outside. This is CK, this is Q, this is Q bar. So the previous example which we have seen is positive edge triggered clock, and now which we are seeing is negative edge trigger clock. So first apply clock. So create period hyphen, so command is create clock hyphen period is 10 nanosecond hyphen name CLK get ports CLK. So here I am applying a clock which is having a time period of 10 nanosecond. Now we have to write generate clock command for GCLK 3 and 4. Now this we are doing it by means of edges. So here this should be written as flip flop 1 Q and this will be flip flop 1 Q bar. So create generated clock hyphen name GCLK3 source coming from clock and edges. So compare GCLK3 with respect to clock. So here I am getting rising edge, falling edge, this is rising edge, this is falling edge. So rising edge is at 2, falling edge is at 4 and again. So here somewhere it will be 5, this is 6, so it will be 6. So 2, 4, 6 are the edges. 2, 4, 6 rise, fall, rise and get pins flip flop 1 Q. Next create generated clock hyphen name GCLK4 coming from CLK and edges. So if you see edges between CLK4, GCLK4 and CLK. So this is rising edge, this is falling edge, this is rising edge. We have to check it with respect to CLK. So this is 4, 5, this will be around 6, this will be 8. So edges will be 4, 6 and 8. So edges are 4, 6 and 8 and it is flip flop 1 Q bar. Here we are not writing hyphen invert. Why? Because this is negative edge trigger and we are writing it with respect to edges. So if you are not writing it with respect to edges, then you have to mention as hyphen invert. So here directly we are using edges, so there is no concept of hyphen invert here. This is very important example. You can see here two clocks are there, C1 and C2, and I told you whenever multiple clocks are there, we need to use a switch called as hyphen add. If you won't write this one, suppose if you write a constraint for C1 and next if you write the constraint for C2 and you forgot to add hyphen add as a switch, then this will be overwritten. So be clear if there are multiple clocks. So let us write the constraint. So create clock hyphen name C1 time period. So here this is 10 nanosecond get port CLK and C2 is 15 nanosecond and I am writing as hyphen add. Remember this. Now write generated clock. So GC1 and GC2 I want. So create generated clock hyphen name GC1 and here I am dividing it by 3. And source it is coming from get ports CLK and in this among C1 and C2 the master is C1. GC1 is with respect to C1, GC2 is with respect to C2 and here GC1 this should be as flip flop 2 Q pin. This is the Q pin and instance name is FF2. Next create generated clock hyphen name GC2. Again I am dividing it by 3. Source it is coming from get port CLK, and here master clock is nothing but C2, and here for G C2 it should be written as flip flop to Q pin, and here add the switch called as -add. So for this particular design it should be written like this. So separately we'll see the examples with respect to edges now. I've taken the same example of divide by 2 waveform. Now we are writing the constraint by using a switch called as edges. So if you are dividing frequency by 2, time period is getting multiplied by 2. So initially I'm taking time period as 10, so it is getting multiplied by 2, it becomes 20. So you can see here the time period is increased to 20 nanosecond. Now write the constraint for this by using -edges. So create generated clock -name. So some name I'm giving as gen clock, and -source, it is coming from CLK. This is CLK, and edges. So here rising edge is at 1, and this falling edge is at 2, and this rising edge is at 3. So edges will be 1, 2, 3. Edges are 1, 2, 3, and get pins. At what pin you want to apply, that pin name you have to give it here. Now see the example of divide by 4. So frequency is getting divided by 4, so time period is getting multiplied by 4. So time period, if you are taking as 10 nanosecond, it is getting multiplied by 4, so it is 40 nanosecond. And mainly see the edges. So here this is rising at 1. Here it is falling at 3, and again it is rising at 5. So edges will be 1, 3, 5. So edges are 1, 3, 5, and the remaining constraint command will be same. So thank you. So in this particular video we have understood how to write the constraint for create generated clock. Please stay tuned to my channel for the next constraints.